All right, so this practice problem lets us really practice the idea of acceleration due to gravity of objects with mass. And so we're just going to utilize that relationship. The first part's going to ask us what's the acceleration due to gravity on the surface of the moon. And the second part is going to ask us what's the acceleration due to gravity on the surface of Mars. So really just practicing this acceleration due to gravity equation. And so we know that the acceleration due to gravity is equal to the gravitational constant g times the mass of the object that's causing the acceleration, all divided by the radius squared. So when we're dealing with planets, the mass of the planet is what we were relating to in terms of the acceleration due to gravity of that planet. And when we are talking about planets, that radius is the radius of the planet. Okay, so for part one, we're asked to do this equation for the moon. So for part A, the mass of the moon is equal to 1.737 times 10 to the 6th. Oh, that's the radius of the moon. Oh, it's the radius of the moon on my two constants upside down relative to how I'm talking. It's 7.35 times 10 to the 22 kilograms. And the radius of the moon is equal to 1.737 times 10 to the 6th meters. So the acceleration due to gravity of the moon is equal to g, and remember g is just a universal constant. G is equal to 6.674 times 10 to the negative 11th newtons times meters squared per kilogram squared. All right, so the acceleration due to gravity of the moon is going to be 6.674 times 10 to the 11th minus 11th times the mass of the moon, 7.35 times 10 to the 22nd, all divided by the radius squared of 1.737 times 10 to the 6th squared. And we get an acceleration on the moon of 1.63 meters per second squared. So that's using that equation, practicing that equation for the moon. Part B has us practicing it for Mars. And so we need to know the mass of Mars. And we have to look that up. That mass of Mars is 6.418 times 10 to the 22nd kilograms. We also need, to the 23rd. We also need to know the radius of Mars. So of an object on that surface, it would have a radius of 3.38 times 10 to the 6th meters. And so we do the same situation we did up here. The acceleration due to gravity on Mars is going to be g. So 6.674 times 10 to the minus 11 times the mass, 6.418 times 10 to the 23rd, all over 3.38 times 10 to the 6th squared. And we find, using that relationship, the acceleration on Mars is 3.75 meters per second squared. So again, just recognizing g is that universal constant, looking up the masses and the radii, and this is really the acceleration due to gravity on a planet. All right.